Hi everyone, I'm Nandita. Today we're going to discuss about cross-lingual information retrieval. So to start off, we know that the world is massive and the internet contains massive volumes of multilingual information, be it in either text format, audio, and video. But the traditional information retrieval systems, they assume that both the query and the documents are in the same language. This is where cross-lingual information retrieval systems come into play. It solves this problem by allowing the users to submit a query in one language, in the language that they know, and also retrieve the relevant documents written in another language. So, for example, a user enters the English query, renewable energy technologies. So let's say some of the best articles they happen to be in either Spanish or French or Hindi or some other language. So the system retrieves the document, they processes the query that we give and retrieves the documents written in the other language on the same topic. So coming to the architecture of CLIR, it starts off with it starts off with the user submitting a query in the source language, while the documents they exist in a target language. And later, a translation happens between the source and the target language, where we convert the user query from its source language to the target language. And then at the representation stage, it converts both the query and the documents into a comparable numerical forms, for example, vectors or embeddings, etc. And later, after getting the documents, we start comparing the documents to find the most relevant documents so this is when we use similarity measures to rank the results. And the most important step, which would be the feedback. So it is an optional step, but it is important because with feedback, the system would be able to refine its refine its retrieval methods, and also rank its also adjust its ranking algorithms. The Since translation is very important, it is one of the integral parts of CLIR. The four core translation approaches are query translation. It is where we translate the user query to the document language. So it is fast, simple, and also it requires low resource cost, but it poses ambiguity issues because when we enter a short query, it loses context and meaning. So then later, the next one is document translation, where we can translate the user documents to query language. So the users would be able to read the results directly, but it is computationally expensive because to translate all the massive documents on the internet to a language that the user gives, it is very expensive and slow. And the next one is interlingual based, where we translate both the query and the documents into a common intermediate language, which provides us with a unified expression. But it requires a complex multilingual mapping. And later, snippet translation, where we translate only the top ranked snippet instead of the full documents. So, this is basically very efficient and user friendly, but it can miss partial context. And later here we have the images for document translation and query translation. In the document translation, the documents are translated into the user's language, and then the documents are retrieved. Whereas in the query translation, the query is translated into the documents language, and then the documents are retrieved and then shown. Okay, and then the main CLIR process, the following steps are included. So let's start off with the query formulation, where the user inputs a query in their native language. But this actually represents the user information, but it necessarily not match the document language. So let's say the English query that I give is renewable energy technologies. Later, in the next step, which is document collection and indexing, where all the documents in that target language they're pre-processed. So that means they're tokenized, they're indexed, they're stemmed, and the stop words are removed. And we can apply TF-IDF or BM25 to compute the term importance as well. And later, for the step 3, which is translation from the source to the target, the user query is basically translated into the document language. for compatibilities. So since we're here using query translation, the user query is translated. So the main techniques include the dictionary based translation, where we translate the words using bilingual dictionaries, that is the two dictionaries, the source and the target's languages dictionaries. And later the machine translation, where we use AI models to predict accurate translations. And later cross-lingual embeddings, for example embird and laser, where we map multiple languages into a shared meaning space, right, shared vector space. So the next step 4, would be document retrieval, which is the query document matching. So the translated query would be compared against the indexed documents using the traditional IR methods to be able to retrieve the most relevant documents. So here we'll be using the techniques that involved in this process. Would be, first we measure the term importance, and then BM25, it considers the term frequency and the document length. And then semantic search, which is which uses multilingual embeddings like embed, so to match the meaning rather than exact words. So in multilingual embeddings, instead of the keyword matching, it focuses more on the context, that is the meaning. So it is very much effective when we use short queries as well. Okay. And then, for example, here the French result is translated to English again as renewable energy technology resources. So the required French documents are required. And later, the document translation, this is actually optional. So if the user doesn't understand the target language, so the retrieved documents, they can be translated back to the user's language for better readability and understanding. So here we can use machine translation tools such as Google Translate, DeepL, and OpenNMP. For example, the French results that you get, they can be translated to English back into English for us to, for me to understand it better, for get the, understand the meaning and for better readability. And later, the final step would be presentation of results, where the system displays the final ranked documents. It can either be in the target language, that is the language the documents are originally in, and or the source language, that is the language I sent the user query in. So the user can toggle between both the versions. So the best example could be in Amazon, in websites like Amazon, where you can switch between languages, or on Google Translate, when you go to a website, you get an option to translate one the given document into another language. That is where CLIR plays an important role. So example, as you user sees the French articles, with a English translation option. And later, the next step would be feedback as well. It is an optional step, but like I said before, it is important for the system to be able to get the user feedback so that it can adjust its ranking algorithms and work better in the future. So now we will see a mini CLIR implementation. So this is the code for this is a mini implementation of CLIR. So first I have installed the required dependencies. We need the IR data sets to load the Hindi data set. Here we've actually used English query and retrieved documents from a Hindi data set. Right. So I have installed the required dependencies. And later I've in the next block I have imported all the necessary libraries that we will be using throughout this notebook, right? And these include tools for data processing, translation, vectorization, and visualization. And later, now we'll be loading the Hindi data set from Miracle, right? Hindi data set. So I'll be loading around 200 Hindi Wikipedia data set documents. This data set, it basically contains real world text passages in Hindi that we will use as our target document collection. So, and later, once they're uploaded, you can see the you can see the preview of few of the documents that are loaded. For few of the 200 documents that we have loaded into this. And later, now the English query that we use is the input query that I use is I want articles related to the history and architecture of Indian temples. That this is my English query. And the target language is Hindi. The documents are in Hindi. Right. So now Since we're using query translator translation here, the query needs to be compatible with the document language, right? So here I'll be using the Google Translate, right, to convert the English query into Hindi. So the translated Hindi query here is Bharatiya Mandiron ka Itihas or Vastukala, right? And later, now I'll be vectorizing. Now we'll be using TF-IDF based CLIR, where this is the first retrieval approach that I'll be using. I'll be using TF-IDF vectorizer, to convert both the translated Hindi query and all the Hindi documents, that the 200 documents that I have, into numerical vectors. That is, I'll be pre-processing, all of that, and then I compute, the cosine similarity to measure how close each document is to the query. Right, I'll be using cosine similarity, and the top ranked documents are here given, the top 10 ranked documents in the target language, which is in Hindi. Right, you've got your 10 languages. You've got the doc IDs, you've got the similarity, and the few preview of the initial sentences of the each document. And now, for better readability, like I said before, if the user doesn't understand the target language, it can be translated back to the user language. So here we have translated all the documents that we have into the the source language. So here, for example, we get results like India's cultural heritage is very rich, and all of these documents are kind of related, they're related to the query that we give. And later here we visualize the TF-IDF scores. Here I have plotted a bar of the bar chart of all the top documents with the cosine similarities and the document IDs. And later, this is the second multilingual approach that I use, where we've moved to this is a more advanced method. Here I've used a pre-trained model, which is mini LM. Right, mini LM. This model basically understands 50 languages, including English and Hindi, and they are the and it places semantically similar sentences closer to closer in a vectored space, shared vector space. The main difference between TF-IDF retrieval and multilingual is that it focuses more on the context, and it works better for short queries when compared to TF-IDF. Right. So unlike TF-IDF, it actually doesn't require explicit translation. And now we have implemented multilingual embedding here. Right, and we've encoded the English query and the Hindi documents and computed the cosine similarity. And then here we have the result, which is with the semantic score, the doc IDs, and the top 10 related relevant documents which to the query. And later, like we have done before, we have translated all these documents to the user language for a better understanding. Here we see that these documents are more related to the query that I've given, and since it's a short query, this actually works better than TF-IDF. Now we are going to here I have compared the TF-IDF similarity and the embedding similarity. So what happens is here is that the blue line shows the embeddings and TF-IDF shows the similarity scores of the orange line shows the similarity score of TF-IDF. Here it shows that you can see that the embeddings have consistently achieved higher similarity score. So this proves that this semantic retrieval captures meaning beyond word translation. So from to conclude all of this, and this is the summary of I've done everything so far. So to summarize, we've actually built a CLIR system that allows a English query to retrieve relevant Hindi documents. We explored both TF-IDF with translation, TF-IDF with translation, which is faster, but it is limited only to keyword matching, whereas and multilingual embeddings, which is more powerful and meaning driven. So this experiment shows how CLIR bridges language barriers, making information retrieval truly multilingual. And I hope you've gotten a better understanding as we've made it to end of the discussion. And thank you.